इतनी ज़्यादा स्लाइड हो गए, हैंग तो नहीं करेगा? आज बचे भी नहीं हैं ज़्यादा, 3 स्लाइड है। चलो good morning, namaskar. Please check audio and video. I got a little bit delayed, sorry for that. Let's begin today's discussion. In the last class we started to study about the electric properties of the materials, and we discussed how energy band is formed for the description of energy of electrons in the solid. There we saw that we have two bands, so one is valence band and other is conduction band, and the electrons initially occupy valence band, and then further if they are provided sufficient energy, they move to the conduction band. When electrons are in the conduction band, they are the free electrons, and those electrons will be participating in the electrical conductivity. Then on the basis of this band gap, we tried to classify material in 3 broad categories, and those we discussed. Those categories were insulator, semiconductor and conductor. So now the chapter will be divided in 3 broad groups. First one is conductors. So let us begin with the conductors. Conductors. This is the first part. Let us put the first heading, that is Ohm's law and electrical conductivity. Ohm's law and electrical conductivity. Ohm's law and electrical conductivity. This is the first heading. The first topic is conductors, and we are going to discuss with this heading. All fine, thank you. Good. Let us consider a metallic rod. Let us consider a metallic rod. Let us consider a metallic rod. I am considering a metallic rod. This is the metallic rod. The length of this rod is L. The length of this rod is L, and there are large number of free electrons. So capital N is number of free electrons. Number of free electrons in the rod. Let us suppose A is cross-sectional area of the rod. A, cross-sectional area of the rod. Cross-sectional area of the rod. Then we can have one quantity defined as N, that is capital N upon L into A. This is number of electrons per unit volume. Something per unit volume is known as concentration of that thing. So this small n is known as electron concentration. Electron means by default free electron. Electron concentration. Anywhere if I am writing electron, it means free electron. Electrons have charge and they are able to move from one place to the another place in the material. So basically they are carrying charge from one place to the another place. That's why they are also known as charge carrier. So it is charge carrier concentration. This is charge carrier concentration. That is number of electrons per unit volume. Now on this material, let us suppose we apply a voltage. Voltage is applied between 2 points, means across the length. So V is applied voltage, and we define a quantity that is known as electric field intensity. that electric field intensity is given as E is equal to V upon L. This is electric field intensity. Electric field intensity. It is defined as voltage per unit length. It is defined as voltage per unit length. Voltage per unit length. Voltage per unit length means volt per centimeter. The unit is volt per meter or volt per centimeter, whatever you say, both are same. So, unit for this is volt per meter. Now, because of this electric field, electrons will start experiencing a force from low potential to high potential. The direction of electric field is always from high potential to low potential. So, high is this point and low is this. So, electrons will be moving like this. When electrons move, they contribute to a current. Current is flowing against the direction of movement of electrons. So, we have I, that is the current flowing through the rod. We define a term J. J is I upon A. So, this I upon A is current density. This is current density. Current density is defined as, it is defined as current per unit area. Current per unit area. It is defined as current per unit area. इसकी यूनिट हो जाएगी एम्पियर पर मीटर स्क्वायर. The unit of this will have ampere per meter square. Current per unit area, that is unit is ampere per meter square, right? Jagan Mohan Rao is asking, sir, is this subject same as material science for mechanical engineering gate service? No, it is different. It is the subject for material science GS paper 1 of engineering services. This is the first slide. Someone asked which slide. This is the first slide. And this is totally different from the GATE syllabus material science of mechanical engineering. That will be taught you separately. Now, you see, my dear friend, these are the some notations I introduced. I would like to discuss few more things here. Suppose this is a crystal. And in this crystal, you are having large number of atoms. Basically, it is a solid. This rod is a solid, and in this solid, you are having large number of atoms. You will get current when electron is moving from low potential to high potential. So, when electron moves in a particular direction, then only the current will be achieved. So, if an electron starts moving from this side, it's not like that it will always keep moving. No. It may get an impurity. And I told you that whenever there is an impurity, it will try to scatter the electron. Yeah, it may collide with any atom and it may get scattered. So, as soon as this electron gets collides, it becomes random and its contribution in current stops. It comes to rest. Like this, suppose this is the pen, this pen is electron and this board. So, this board is atom and this pen is electron, it is moving. So, when it is moving and it will collide, then it will come to rest. It will get scattered and come to rest. So, an electron starts moving under the force of this electric field from 0, and this is, let us suppose, 0 level. It starts to move, it keeps on moving, its velocity increases, but at certain points collision takes place. It collides, right? So when collision with any atom or impurity takes place, the electron comes to rest. Immediately its velocity becomes 0. This is 0 level. Then again electric field is everywhere. So this electron again takes electric field and again starts to move, again get collide and scattered. So it starts to increase its velocity, reaches up to certain point and then again gets collide and gets scattered. Then here it again starts taking energy from the electric field, starts moving and then again get collides and scattered. So again its velocity keep on increasing to a certain value, it gets collide and then scattered. So you see electron cannot continuously accelerate under the field, under the electric field. Instead it starts accelerating from this point and goes up to this point. Again comes to rest, start accelerating and goes to this point. So if I take this as t is equal to 0, this point as t is equal to 0, so here velocity of electron is 0. Then this time is time between two collisions. This is tau c, right? And here velocity of electron is given as bd, drift velocity. So from 0 to tau c, it means between the collision whatever velocity acquires the electron, that is known as drift velocity. So tau c is average collision time, average collision time, average collision time. It is the time between two successive collisions. It is the time between two successive collisions. It is the time between two successive collisions. This tau c is function of temperature 1 upon root T. As you keep on increasing temperature, lattice vibration will increase. So scattering of electron increases, means collision of electron with atoms increases. So collision time decreases. And if collision time decreases, then obviously the velocity acquired by the electron will also decrease. Here I have shown V is equal to Bd. Bd is known as drift velocity of electron. Bd is drift velocity of electron. Drift velocity of electron. It is the velocity acquired by electron under the influence of an applied electric field. It is the velocity acquired by electron, acquired by electron. It is the velocity acquired by electron under the influence of an applied electric field, an applied electric field. It is the velocity acquired by the electron under the influence of an applied electric field. This is all about the notations in Ohm's law. ठीक, मुझे ये वेलोसिटी कैलकुलेट करना है, कैसे कैलकुलेट कर सकता हूँ जरा देखिए. मैंने इलेक्ट्रिक फील्ड लगाया तो फोर्स experienced by electron due to applied field, I'm just calculating magnitude of force. I'm not interested in direction. So it is Q into E, charge of electron multiplied by electric field. ये basic relation है, आपको याद रखना पड़ेगा, फिजिक्स से लिया हमने. This force must be equal to Mn, mass of electron, into acceleration. Mn is mass of electron, and A is acceleration due to force, या acceleration of electron. Now my dear friend, you know that acceleration is Mn is dB upon dt. This is rate of change of velocity. So that is q into E. So from this we can have dB upon dt is equal to QE upon Mn. This can be written as dB is equal to QE upon Mn into dt. So if I go 0 to tau c, right, I go from here to here. This is t is equal to 0, so velocity is 0. Tau c, up to tau c time it's increasing its velocity, then colliding. When collision took place, it comes to rest. It gets scattered and comes to rest. So at t is equal to 0, velocity is 0, and at t is equal to tau c, velocity is bd. If you integrate this, so integration of dB is b, so it is bd minus 0. QE by Mn is constant, take it outside. Integration of dt is t, so it is tau c minus 0. So from this we have bd is equal to QE upon Mn into tau c. You can write it like this: bd is equal to q tau c upon Mn into E. My dear friend, this is the expression for drift velocity of electron in the solid. It is drift velocity of electron, drift velocity of electron, From this expression you see BD is directly proportional to applied electric field. So BD is directly proportional to E. We can have a proportionality constant BD is equal to mu n into E, where mu n is equal to this value q tau c upon Mn, q tau c upon Mn. This mu n is known as mobility of electron. Mu n is known as mobility of electron, mobility of electron. This mobility is defined as mu n is equal to bd upon E. So it is defined as drift velocity per unit applied field, per unit applied electric field, drift velocity per unit applied electric field. It is defined as drift velocity per unit applied electric field. So these are the few terms, few definitions we need to know. I started with some fundamental notations and definitions. If first right, then I would be reaching towards Ohm law on discussing few things. Please note down. बेटा 10th भी नहीं पढ़े हो क्या? इलेक्ट्रॉन करंट वोल्टेज अलग होते हैं कह रहे हो ओंकार बेटा? ये तो 10th वंथ पढ़ लेता है जो बच्चा, वहीं पता चल जाता है. सो इवन इफ यू हैव नॉट डन 10th तो कैसे काम चलेगा? बताइए. फर्स्ट टॉपिक है, अभी कोई टॉपिक मिस नहीं हुआ. दिस इज द फर्स्ट टॉपिक वी स्टार्टेड टुडे. Yes, Ashish. Write down these things. Pratik, collision generally takes place between electron and atom. Although it may take place between electron and electron, but probability of electron and electron collision is negligible. Still, if any electron is moving and it collides with electron, it will get scattered. If it is getting scattered, it is losing its velocity. If it is losing its velocity, I am interested in that velocity. So be it the collision happens with the atoms, impurity or electrons, it hardly matters for us. For us, what matters is if the collision is happening for this electron, then it is coming to rest. That we are wanting to discuss. But in general, the collision happens with the atom and electron. Atoms are vibrating around their mean position and an electron is moving. So an electron may get scattered by this vibration. It means it may get collided by the atom. Achilles, even if there is no impurity, still collision will take place because material would be definitely at certain temperature, and at that temperature there would be atomic vibration. So electrons would be colliding with that atomic vibration. हाँ, अगर आप ये मान लें कि your material is at 0 Kelvin, then obviously there will not be any collision. Done? Shall we go ahead? आगे बढ़ें. Good morning, Nishtha. Nishtha has asking a question, sir. I want to know that as IRM SE exam notification came yesterday and I belong to EC branch, so should I go for this exam taking electrical engineering as optional? How the subjects like power system and power electronics will make raise difficulties? Nishtha, actually in UPSC सिविल सर्विसेज देर वॉज नेबर ईसी, कभी भी उनके पास में ईसी नहीं था, इलेक्ट्रिकल इंजीनियरिंग ही था। तो उन्होंने अभी जो IRMS का नोटिफिकेशन दिया है उसमें बेसिकली क्या किया, आप नंबर ऑफ वैकेंसीज देखो तो आपको अंदाज़ा लगेगा कि सिविल में 30 हैं, मैकेनिकल में भी 30 हैं, अकाउंटेंसी वाला जो है आपका कॉमर्स एंड अकाउंट उसमें भी 30 हैं, लेकिन इलेक्ट्रिकल में 60 हैं। तो बेसिकली ये इलेक्ट्रिकल नहीं है, ये इलेक्ट्रिकल प्लस ईसी है। इन दोनों की 30-30 वैकेंसी मिला करके इसको 60 कर दिया है। तो हमेशा इलेक्ट्रिकल में जो वैकेंसीज आएंगी वो डबल आएंगी, यानी मोर होंगी रादर देन द अदर डिपार्टमेंट्स, अगर उनको इक्वल रखना होगा तो। अगले साल देखेंगे क्या होगा, अभी तो फिलहाल यही। अब इसमें जो इलेक्ट्रिकल इंजीनियरिंग का सिलेबस है वो ना ही प्योर इलेक्ट्रिकल है और ना ही प्योर इलेक्ट्रॉनिक्स है। जैसे इलेक्ट्रॉनिक्स के स्टूडेंट को पावर इलेक्ट्रॉनिक्स, पावर सिस्टम और मशीन में प्रॉब्लम होगी। दीज 3 सब्जेक्ट्स आर डिफरेंट। ठीक उसी तरह से इलेक्ट्रिकल स्टूडेंट को कम्युनिकेशन इन डेप्थ पढ़ना पड़ेगा, जो कि ये लोग नहीं पढ़ते हैं। ठीक है, कम्युनिकेशन इनको इन डेप्थ पढ़ना पड़ेगा। इसी तरह से इन्हें और भी कई सारे अपने जो सब्जेक्ट होते हैं, जैसे माइक्रो प्रोसेसर है, चलो आजकल तो माइक्रो प्रोसेसर इनके गेट में आ गया तो थोड़ा बहुत पढ़ते हैं। एनालॉग इलेक्ट्रॉनिक्स ये लोग बहुत अच्छे से नहीं पढ़ते हैं, दे हैव टू स्टडी एनालॉग इलेक्ट्रॉनिक्स इन डेप्थ। डिजिटल इलेक्ट्रॉनिक्स इलेक्ट्रिकल के सिलेबस में कम है, लेकिन ईसी के सिलेबस में काफ़ी ज़्यादा, तो इनको इन एरियाज में डिफ़िकल्टी फील होगी। तो कंपटीशन जो है वो बैलेंस्ड रहेगा दोनों ही ब्रांचेस के लिए। मैं सलाह दूंगा कि ये टॉप देना चाहिए एग्जाम, पहली बार तो जरूर देना चाहिए। दिस ईयर वाई वन शुड अपीयर, बिकॉज अभी 6 मंथ बचा हुआ है, तो बहुत सारे लोग माइंड ही मेकअप नहीं कर पाएंगे। देयर वुड बी लॉट्स ऑफ पीपल हु विल नॉट बी एबल टू इवन थिंक अबाउट दिस एग्जामिनेशन। सो व्हाट आई एक्सपेक्ट कि दिस ईयर सिंस एग्जाम इज कंडक्टेड फर्स्ट टाइम, सो देयर इज अ वेरी हाई प्रोबेबिलिटी कि द कट ऑफ विल गो डाउन। हाउ टू प्रिपेयर फॉर दीज टॉपिक्स, उसका कुछ ना कुछ मेडिजी विकल्प लेकर के आएगा। अगर मेरा डिस्कशन हुआ सर से, अभी तो नहीं हुआ है, मैं जस्ट एक अपना आइडिया दे रहा हूँ कि मैं कोशिश करूँगा कि एक पैकेज के टर्म में सर एक ऑनलाइन कोर्स कुछ ऐसा दे दें 1 महीने 1.5 महीने का, जिसमें जो 3 डिफरेंट सब्जेक्ट हैं दोनों ब्रांचेस के लिए एक मॉड्यूल बना दें कि जो डिफरेंट सब्जेक्ट्स हैं वो बच्चे ऑप्ट कर सकें। या आप कहीं से भी फोटोकॉपी नोट्स की करा लीजिए, जो नोट्स हैं उनकी फोटोकॉपी करा लीजिए इन सब्जेक्ट्स की, इलेक्ट्रिकल के किसी दोस्त से मांग करके, और प्रीवियस ईयर क्वेश्चन लेकर के खुद से करने की कोशिश करिए। ये इंजीनियरिंग बैकग्राउंड के ही सब्जेक्ट हैं तो आप कर ले जाएंगे, ऐसी कोई बड़ी बात है नहीं। थोड़ा डिफिकल्ट तो होगा क्योंकि आपके कंफर्टेबल डोमेन से बाहर की चीज़ें रहेंगी, बट बड़े एग्जाम निकालने के लिए अपने कंफर्ट से तो बाहर आना पड़ेगा। मैं इस नोटिफिकेशन का मैं कल देख रहा था, बहुत सारे लड़के इधर उधर कमेंट कर रहे थे जब मैं सर वीडियो अपना रिलीज किए शाम को कि ये बेकार है, एब्सर्ड है। देखो, एक तरफ तो पूरी तरह से वैकेंसी हाथ से चली गई थी, इंडियन रेलवे में इंजीनियर्स का रिक्रूटमेंट ही बंद कर दिया था। तो पता नहीं कहाँ से अब उनके दिमाग में क्या आया, कैसे आया कि एटलीस्ट उन्होंने फिर से आपको वापस वैकेंसीज दे दी, और उसमें टोटल वैकेंसी में 3/4 वेटेज जो दिया है वो इंजीनियरिंग ब्रांचेस को दिया हुआ है। सो कुछ ना सही से कुछ तो सही है। बाकी रही बात इफ़र्ट करने की, तो एक होलिस्टिक इफ़र्ट किया जाए। कई सारे लोग उसमें एब्सर्ड लॉजिक लिख रहे थे कि अगर जीएस इतना ही आएगा तो सिविल सर्विसेज निकाल लेता ना। भाई, सिविल सर्विसेज में जो तुम्हारा कंपटीशन होगा वो सिविल सर्विसेज के एस्पिरेंट्स के साथ होगा, बहुत हाई कट ऑफ जाएगी। उनका जीएस पे नॉलेज बहुत अच्छा होता है। यहाँ तुम्हारा प्रीलिम्स का भी जो कंपटीशन होगा वो कंपटीशन होगा सिर्फ आईआरएमएस जो लोग दे रहे हैं उनके साथ में। तो ऑब्वियसली जब आईआरएमएस देने वाले सारे इंजीनियर्स ही हैं तो प्रीलिम्स की कट ऑफ बहुत ज़्यादा नहीं जा सकती है एज कंपेरिजन टू द सिविल सर्विसेज या उस तरह। हाँ, अगर सारे इंजीनियर्स जीएस बहुत अच्छा पढ़ लिए तो कट ऑफ ज़्यादा भी जा सकती है, बट इंजीनियर्स कितना अच्छा जीएस पढ़ते हैं हमें आपको सभी को बहुत अच्छे से पता है। एंड अब यार ये बड़ा हमारे सब्जेक्ट से हम डिरेल हो जाएंगे, बहुत सारे क्वेश्चन आप लोगों ने। इन आईआरएमएस वी हैव इंडियन लैंग्वेज दैट इंक्लूड इंग्लिश आल्सो। नो, इंग्लिश इज डिफरेंट एक्चुअली, इंग्लिश एंड एनी वन इंडियन लैंग्वेज। सो वो इंग्लिश तो चाहिए ही चाहिए, उसके अलावा कोई एक इंडियन लैंग्वेज। सो दो लैंग्वेज के पेपर क्वालिफाइंग हैं, दे आर जस्ट क्वालिफाइंग कि आपको ये भाषा आती है या नहीं आती है, उतने नंबर लेकर के आना है, उनके मार्क्स फाइनल लिस्ट में नहीं ऐड होंगे। एंड सीएससी जीएस इज डिफरेंट। सीएससी जीएस तो इस सब्जेक्ट में तो नहीं कंप्लीट होगा, ये कोर्स में नहीं होगा। प्रीलिम्स में दो पेपर होते हैं एंड प्रीलिम्स में कोई भी टेक्निकल नहीं होगा, प्रीलिम्स सिर्फ जीएस और सीसैट होगा। अब अभी इस क्लास में इतना कुछ डिस्कस करने का टाइम नहीं है, कभी मैं अपने ग्रुप वगैरह पर इसके रिगार्डिंग कुछ बातचीत कर लूँगा, क्योंकि फिर पूरी क्लास डिरेल हो जाएगी। ठीक है, तो अभी बात करते हैं, पढ़ते हैं। किसी ने एक बड़ा अच्छा क्वेश्चन पूछा हुआ है कि इफ आई अपीयर इनटू आईआरएमएस विल इट बी काउंटेड एज सिविल सर्विसेज अटेम्प्ट। नहीं, वो आपसे पूछेंगे फॉर्म में कि आप सिर्फ आईआरएमएस के लिए जा रहे हैं या सिविल सर्विसेज के लिए जा रहे हैं या बोथ के लिए जा रहे हैं। अगर आपने बोथ टिक किया है देन ओनली आपका सिविल सर्विसेज का अटेम्प्ट काउंट होगा। अगर आपने बोथ के लिए नहीं अप्लाई किया है, सिर्फ आईआरएमएस के लिए अप्लाई किया है, तो आपका सिविल सर्विसेज का अटेम्प्ट काउंट नहीं होगा। चलिए प्लीज कम बैक, लेट्स कम बैक टू आवर डिस्कशन। According to Ohm's law, according to Ohm's law, Ohm's law के हिसाब से V is equal to RI. We all know that. Actually, B is directly proportional to I. R is just a proportionality constant. इस बात का विशेष ध्यान रखा जाना चाहिए। R is equal to rho L upon A. So R is resistance. This is resistance of material. ओम में रिप्रेजेंट होगा। L आप जानते हैं, A जानते हैं, rho is resistivity of material. It is material property. Resistivity of material. If you try to calculate the unit, so RA by L, rho के लिए A की यूनिट मीटर स्क्वायर, L की मीटर, मीटर मीटर कैंसिल, दिस विल कम इनटू ओम meter. Here we define a very important quantity that is known as electrical conductivity. Electrical conductivity, electrical conductivity, electrical conductivity, which will be denoted as sigma, is defined as reciprocal of resistivity, is defined as reciprocal of resistivity. Reciprocal of resistivity is defined as reciprocal of resistivity. It means sigma is equal to 1 upon rho. So unit of sigma क्या हो जाएगा? Unit of sigma is ohm meter inverse या मोहो पर meter, yeah, it is known as Siemens per meter, right? Now if I put this value of R, V is equal to rho L upon A into I. So we will be having I upon A, this is equal to 1 upon rho V upon L. I upon A is J and 1 upon rho is sigma and V upon L is E. this all we have defined. So this equation, let us suppose it is equation 1, it is another form of Ohm's law, another form of Ohm's law, another form of Ohm's law. It is another form of Ohm's law. Please reach up to this point. According to Ohm's law, कुछ चीजें हमने define की हैं. Karthik Arvind, since this notification has come yesterday, so in coming few days the courses will be planned by Medici. So let's see. Just you need to wait. Yes, Alok Nathni, the IRMS means cutoff will be decided only on the basis of two papers. Those are 250 marks. Good. Now you see. Current can be calculated from general definition also. What is that general definition? Current flowing through the rod, flowing through the rod. I is equal to charge per unit time. How much charge is there? Total n electrons. Each electron is having q coulomb charge. Q is magnitude of electronic charge. I may have told you in the very beginning. This is given like this. And time taken by these charges to move from one end of the material to the other end. Have a look here. You see, an electron is moving with drift velocity, and then it is able to cross from this into this end. So this length is L and velocity of electron is Vd. So Vd is equal to L upon time. So time is how much? L by Vd. This would be the time taken by the electron to move through this material. Length upon drift velocity. So let's put this value of time. Let's put this value of time. So we have I is equal to NQ upon L by Vt. So this comes out as I is equal to N by L Q into Vd. So current per unit area. So current per unit area, that is current density. J is equal to I upon A. So I is N by NQVD L into A. You can write it like this. J is equal to N upon L into A into Q into BD. So this comes out as J is equal to NQVD. This J is equal to NQVD. J की value हो गई. Now my dear friend, you see J is equal to NQBD. BD is equal to mu n E. B have, this is small n. I have told you already, number of charge per unit volume. BD is equal to mu n into E, that we have written few moments before. So if I put this value, so J is equal to NQ mu n into E. Let us suppose this is equation number 2. Now we have two equations, one this J is equal to sigma E and another is J is equal to NQ mu n into E. If I compare these two equations, comparing equations 1 and 2, comparing equations 1 and 2, sigma is equal to NQ mu n. This is the conductivity of a material. Here one important observation should be done. Conductivity depends on two factors. Q is constant, 1.6 into 10 raised power minus 90. Conductivity depends N and mu n. So on the basis of only electron concentration, you should not comment about the conductivity. You should know both things. Electron concentration as well as mobility of electron. Mobility is denoting just drift velocity of electron, how quickly the electron is moving, that is indicated by the mobility. So first you write this, then we would be discussing few more things related with this here onwards. नहीं, prelims is just qualifying. Prelims marks will not be added in the final result. Final result would be from mains and interview marks only. Yes, appearing students can apply. Sorry Kumar, Telegram channel name is Anunad. I have told in several lectures. Even in the first lecture I told it. It is t.me ANUNAAD22. That is Anunad. Let's be in resonance. Shall we go ahead? We have mu n is equal to, just few moments before we have written mu n is equal to q tau c upon mn. So if I put this value, then I can have sigma is equal to nq into q tau c upon mn. So sigma is equal to nq square tau c upon mn. This is the another relationship for conductivity. Friends, Q is constant, that is 1.6 into 10 raised power minus 19. Mn is mass of electron constant 9.1 into 10 raised power minus 31. So we can have this relationship written as sigma is directly proportional to n into tau c. I told you in the beginning that tau c is inversely proportional to root of temperature. So this relationship can be written as sigma is directly proportional to n by root of temperature, right? This is our conductivity expression. This is conductivity expression. My dear friends, yesterday I told you that with increase in temperature, there is no increase in number of free electrons in metals. कल की ही क्लास में मैंने आपको बताया था कि टेम्परेचर बढ़ाने पर सेमीकंडक्टर्स में तो इलेक्ट्रॉन बढ़ेंगे, लेकिन मेटल्स में टेम्परेचर बढ़ाने पर देयर इज नो इंक्रीज इन नंबर ऑफ फ्री इलेक्ट्रॉन्स. It means n will remain constant. But if you increase temperature, then sigma will decrease. If n is constant, so you are increasing temperature, tau c is decreasing, sigma is decreasing. So we can have one important observation that for the metals with increase in temperature, conductivity decreases and resistivity increases. Resistivity is reciprocal of conductivity. So if conductivity is decreasing, resistivity will increase. We can say that in metals, with increase in temperature, there is no appreciable increase in free electron concentration. But significant decrease in average collision time. Significant decrease in average collision time. Hence, conductivity decreases and resistivity increases with increase in temperature. Very important conclusion. They may be asking several times, in metals with increase in temperature, what happens with conductivity? So you can justify like this. So please note down this. बिल्कुल मैं स्लो चलूँगा. Obviously, there would be range of resistivity, Ashish Mukherjee, for determining conductivity and all these parameters. Done? Trishali is asking, sir, for GS separate PIQ book is not provided. Yes, dear. GS previous year questions are included in the theory book. So you can refer the theory book. At the end of the each chapter, those questions has been included. So there is no separate book. The theory book which you have been provided, that includes previous year questions as well. Ishu Yadav is asking, these all formulas I have to remember. Aapki ichha, whether you remember or you don't remember. Right. Now you see, my dear friends, let us revisit electrical resistivity again, and let us try to figure out few things related with resistivity of metals. So put a heading, electrical resistivity of metals. Electrical resistivity of metals. We all know that metals are very good conductor of electricity. So reciprocal of conductivity is known as resistivity. Reciprocal of conductivity is known as resistivity. Metals are very good conductor of electricity and reciprocal of conductivity is known as resistivity. You see, my dear friend, resistivity is directly proportional to N and mu n. But in metals, number of electrons cannot be changed. So number of electron is almost constant. So sigma is directly proportional to mu n, and mu n is directly proportional to tau c. Tau c is time between two collision. So that is time before the electron get scattered. So if more collisions are taking place, higher will be scattering and less will be collision time. If collision time is less, mobility is less, conductivity is less, resistivity will be high. If less is the collision, less will be the scattering, larger will be the collision time, and higher will be mobility, higher will be conductivity. Now you recall, in last class I told you that crystalline defect serve as a scattering point for the movement of electron. So if there are defects in the crystal, so they will scatter. When electron is getting scattered, it means it is becoming random. Its contribution in electrical conductivity is getting stopped. So if number of impurities are more, then scattering will be more, and if scattering will be more, means time between the collisions, या time between the scattering is less. So I can say that larger the defect in the material, higher is the scattering, lesser is the average collision time, lower is the mobility, lower is the conductivity and higher is the resistivity. किसी मटेरियल में जितने ज़्यादा डिफेक्ट होंगे उतना ज़्यादा इलेक्ट्रॉन स्कैटर होगा, जितना ज़्यादा इलेक्ट्रॉन स्कैटर होगा टाइम बिटवीन टू स्कैटरिंग इवेंट उतना ही कम होगा, यानी टाउ सी की वैल्यू कम होगी। टाउ सी की वैल्यू कम होगी तो मोबिलिटी कम होगी, कंडक्टिविटी कम होगी, रेजिस्टिविटी बढ़ जाएगी। यही लिखाना चाहता हूं मैं। नाउ यू सी माय डियर फ्रेंड कि दिस defect will depend mainly on three factors. The amount of defect in a material will be decided by the three factors. First, temperature. Temperature vibrates atom. This is also a kind of defect which will scatter the electron. As well as temperature may create vacancies, and that vacancies also function as a defect. The first factor can be temperature. Second factor can be amount of impurities added. If you are adding any impurity in the material, so either it will form substitutional or it will form interstitial. Certain kind of defect it is going to form, and if there is a defect it is going to scatter the electron. Third one is plastic deformation. Plastic deformation means changing the shape of the material. So to change the shape of the material, you will apply certain force. And because of that force, electrons will leave their original position. Whenever electron is leaving their original position, then a defect is created. I told you, whenever there is change in order or periodicity, there would be a defect. So these plastic deformations actually dislocate atoms, and these dislocations are nothing but the defect. During plastic deformation, we do cold working, we do recrystallization also. All these phenomena create defect. I told you that during recrystallization, if rate of cooling is high, then amorphous material may become. If rate of cooling is low, then crystal will become. If rate of cooling is moderate, then material with certain defect may result. So if rate of cooling is higher, then there is a high probability of more number of defects in the material, and hence resistivity will increase. So we are wanting to investigate all these three areas: temperature, and then amount of impurity, and the third one is plastic deformation, या cold working, या rate of cooling. All these factors which are basically done to change the shape of the material. So let's write crystalline defect. Crystalline defect serve as scattering point for the movement of electron. Crystalline defect serve as a scattering point for the movement of electrons. Crystalline defect serve as a scattering point for the movement of electrons. Hence, average collision time becomes less if material has large number of defects. Therefore, mobility decreases and resistivity increases. Mobility decreases and resistivity increases. Therefore, mobility decreases and resistivity increases. Mukul, in the last class when I was discussing vacancy, I told you कि vacancy is what? Absence of atom. ठीक? तो suppose you increase temperature, because of temperature some bond may be broken, and if the bond is broken, then atom will become free from the influence of neighboring atom. So this atom will take this thermal energy and it will move. So a vacancy would be created on the place where the atom was, right? And that is the reason at high temperature, when you reach to the melting point, all the atoms are leaving their position and they are moving, they are starting to flow. Why? Because the bonds with the neighbors will break down and they will become free from the influence of the neighbors. So they take this thermal energy and they start moving, right? आइए लिख लीजिए इसे। अभिषेक नागदेशी पूछेंगे, सर आप ग्रीन टी पी रहे हो क्या? अब मैं दोनों तरह की चाय पीता हूँ, नॉर्मल टी भी पसंद है और ग्रीन टी भी पसंद है। बेसिकली टी होना चाहिए, वो कोई भी हो। तो चाय पसंद है और किसी भी तरह की हो, वो चाहे ग्रीन टी हो या ग्रीन टी में एक गिरनार की आती है डिटॉक्स करके, वो बहुत अच्छी लगती है। सारी ग्रीन टी नहीं अच्छी लगती, बट गिरनार की एक बहुत अच्छी लगती है। Mobility decreases and resistivity increases. Resistivity increases. The concentration of these crystalline defects, the concentration of these crystalline defects depend upon the following factors. First, temperature. Second, impurities. Third, plastic deformation. या the amount of cold working. etc. Cold working की exact meaning I would be discussing in chapter named as mechanical properties of materials. Hence, total resistivity of metal, is sum of contribution from thermal, second impurities, third plastic deformation. So you can write it mathematically as, that is, rho total is equal to rho thermal plus rho impurity plus rho plastic deformation. This equation is known as Matheson's rule. It is known as Matheson's rule. Matheson's rule says that कि total resistivity is sum of contribution from various factors. Those factors are temperature, impurities and plastic deformation. So all these are the factors which are responsible for the total resistivity of the material. Then now we would be discussing each and every factor individually. So let us discuss factors affecting electrical resistivity of metal. Factors affecting electrical resistivity of metals. Resistivity of metals. First factor is temperature. The very first factor is temperature. I discussed in the last reading that if we increase temperature, mobility decreases and conductivity decreases and resistivity increases. So we discussed in the last reading, if temperature is increasing, resistivity, conductivity is decreasing and resistivity is increasing. This resistivity can be given as rho T2 is equal to rho T1 1 plus alpha into delta T. This way the resistivity can be written as, where rho T2 is resistivity at temperature T2, resistivity at temperature T2, resistivity at temperature T2. Rho T1 is resistivity at temperature T1, resistivity at temperature T1. Delta T is T2 minus T1. Alpha is temperature coefficient of resistance. Temperature coefficient of resistance. Temperature coefficient of resistance. It is always positive value. Why? Suppose if it is negative value, then rho T2 will be less than rho T1 if delta T increases, right? But that is not possible. As we are increasing temperature, then resistivity must increase. So if delta T is positive, rho T2 must be greater than rho T1, और ऐसा तभी संभव है जब अल्फा की वैल्यू पॉजिटिव हो. So alpha is positive always for the metals. It may be different for other materials, but positive value for metals. Positive value for metals. Alpha is positive value for metals. This relation is useless for us. Just I am telling you this relation, but not useful. The useful relation is in terms of resistance. So you have to remember that relation. RT is equal to R naught 1 plus alpha into T. This is the relation which is useful. You have to memorize this relation. This is basically experimental result and it is valid on the centigrade scale. So you have to put the temperature in centigrade scale and you should know what are the various parameters meaning here. RT is resistance at T degree centigrade. Resistance at T degree centigrade. R naught is resistance at 0 degree centigrade. Resistance at 0 degree centigrade. Alpha is temperature coefficient of resistance. Temperature coefficient of resistance. Temperature coefficient of resistance, that is centigrade inverse, right? This is very important relationship. They have asked questions, numerical problems on this relationship. So you remember this one. आपको इसको याद करने की कोई ज़रूरत नहीं, वो theoretical है, that's why I told you. But actually this relation is very important and this you have to remember. Please note down this relation, then I would be giving you one numerical problem and then we would be moving forward. Nishtha, you can write me. As such, I cannot tell you the exact time because the whole day I am in the classes. So you please write down me at Telegram personal message box, and after that I will tell you the time when you can contact me. And if your doubt is a small one, I will be replying in Telegram message box itself, but if something is specific, then I will give you proper time, but as of now it is not possible to tell the exact time, right? Because the whole day I have different kind of schedule. Probably you may be watching today I am in little bit different dress because I have different types of video shoot regarding different kind of courses and all that. So आज तो बिल्कुल भी ये कह पाना मुश्किल है कि कब exactly free होऊंगा, but still you write down, I will be telling you time. Sir, preparing triple exam GATE, ESC and RMS for engineers is difficult. ये बेवकूफ़ी है, मैं इससे इत्तेफाक नहीं रखता हूँ ऋत्विक. I do not agree with this. This is totally idiotic thing. Easy choices in the beginning makes life difficult in the later on stages, and hard choices in the beginning makes life easy in the later on stages. So it depends upon you. If you want to achieve something bigger, you are going for group A gazetted officer post and you are saying that it is very difficult. Obviously it is difficult, that's why people are getting such a big thing in the life. How can you expect that you can easily become an officer, you can easily get the things? No, it's not possible. And all these examinations are having 60% syllabus extra. If you see, what my assertion is, if as a student I see, technical is common, right? Technical syllabus is roughly around 800 to 1000 hours. This is the biggest part, biggest syllabus you have to prepare, right? Now, this syllabus covers your GATE examination only. In this syllabus, math and aptitude has already been covered, right? Now add 200 hours extra. So this 200 hours extra is ESC prelims GS. So this is ESC prelims GS. Now add 300 hours more. You add this for history, geography, polity, economy, life science and current affairs. Current affairs already you study here also in 200 hours, still I am writing here. So if you study 1500 hours, right, then any examination in India you can appear and crack, be it IES, IRMS, PSUs, separate exam, state engineering services, SSC, GATE, any examination of the technical field, lectureship examinations in states, they keep on doing. Lots of, I was few days back, I was planning a seminar to deliver in the colleges. Actually, in January to May, we have very less batches. So MEDG organizes my seminars in various colleges. So roughly around 100 colleges of country are every year planned. And I used to visit those colleges to deliver my thoughts regarding the jobs and all those things after career BTech what one should do. I'm not saying that it is easy. If you are wanting easy things, then go somewhere, start doing something. Don't start preparing for competitive examinations. Competitive examinations are never easy path. Easy things will retain you in the comfortable domain, and in the comfort domain you are not going to achieve big things in your life. So ये उन लोगों के लिए competition होता ही नहीं है जो छोटी सोच के लोग होते हैं. Competition word अपने आप में क्या कह रहा है कि you have to compete with the others. It means you have to prove yourself in comparison to the larger crowd. एक बड़ी भीड़ के सामने आपको खुद को प्रूव करना है कि मैं सबसे अच्छा हूं, तो ये कभी आसान काम हो ही नहीं सकता. ये तो हमेशा एक डिफिकल्ट काम होगा. ठीक है. सो अगर आप 1500 घंटे ठीक से पढ़ रहे हैं तो जितने भी एग्जाम, एंड एक अच्छी बात है कि अगर आप ये 1500 घंटे के साथ में यू हैव नाउ स्ट्रांग फाउंडेशन फॉर हिस्ट्री, ज्योग्राफी, पॉलिटी, इकोनॉमी, लाइफ साइंस एक्सेट्रा, इन सबकी स्ट्रांग फाउंडेशन है. अगर आप सिविल सर्विसेज का मूड बना रहे हैं तो इसके बाद आप सिविल सर्विसेज के लिए भी 200-300 घंटे 400 घंटे और पढ़िए एंड यू कैन गो फॉर द सिविल सर्विसेज एज वेल. हालांकि इतने से सिविल सर्विसेज तो नहीं होने वाला है. सिविल सर्विसेज इज समथिंग बिग गेम, वो बहुत बड़ी चीज है. बट 1000-1500 घंटे पढ़ना इट्स नॉट अ बिग डील माय डियर फ्रेंड. और इतना पढ़ना पड़ेगा merely just by getting degree. You are not going to get job. सिर्फ डिग्री पा करके, और डिग्री चाहे जितनी अच्छी जगह से होगी उसका कोई मतलब नहीं है जब तक उसमें वैल्यू नहीं होगी, कंटेंट नहीं होगा. अरे अभी प्रीलिम्स निकालो, मेंस की बात बाद में करेंगे. लेट अस कम बैक टू द पॉइंट्स व्हिच वी वर डिस्कसिंग. लेट्स कम बैक. आई प्लीज नोट डाउन अ क्वेश्चन. A resistor measures 4 ohm at 40 degree centigrade and 6 ohm at 80 degree centigrade. What value the resistor will measure? The resistor will measure at 0 degree centigrade. Option A 1.5 ohm, option B 2 ohm, C 3 ohm, D 4 ohm. This was question asked in Engineering Services 2017 ESC prelims में ये पूछा गया था, GS में. प्लीज डू इट. करिए इसको, आंसर बताइए मुझे. बिल्कुल, हार्डर द बैटल स्वीटर द विक्ट्री. देखो ना, एक होलिस्टिक अप्रोच रखने की जरूरत है. अगर आप पास हो गए हैं तो 1 साल 1.5 साल बैठ करके खुद को दे दीजिए, सारे एग्जाम आपके निकल जाएंगे. अगर आप कॉलेज में हैं, दैट इज द बेस्ट टाइम टू स्टार्ट द प्रिपरेशन. मैं कॉलेज में फर्स्ट ईयर में मुझे समझ में आ गया कि बहुत बड़ा कुछ कॉलेज से नहीं होने वाला है. प्राइवेट कॉलेज था एंड आई वाज नॉट नोइंग मच अबाउट द इंजीनियरिंग. आई ट्राइड माई बेस्ट फॉर IIT JEE, कुडंट क्वालिफाई IIT JEE, और उसके बाद एक प्राइवेट कॉलेज से इंजीनियरिंग करने पहुंच गया. एंड आई वाज नोइंग दैट कि बहुत कुछ कॉलेज से मुझे यहाँ मिलेगा नहीं. Although I got placement from the college, but that placement was not as per my expectation. Private colleges give very small package placement. At that time it was 3.96 lakh rupees per annum. So that was a miagra, ऊंट के मुंह में जीरा टाइप वाली बात थी. So in the second year I came to know it very early stages. So I start again recollecting my energy to prepare for the competitive examination. And by the third year, I started my preparation in full-fledged. In the final year, I took the coaching in MEDG. And along with the college, I cracked GATE examination. I got a job in central government, and then I keep on pursuing my other dreams. I started to prepare for civil services and then so on. So आदमी उसके बाद तो एक बार जब जीवन में कुछ मिल जाए तो आप जितना मेहनत करिए, जितना आगे उसको अच्छा बना सकिए उतना बनाने की कोशिश करिए। नहीं बन पा रहा तो कोई बात नहीं है, लेकिन कम से कम एक मिनिमम सिक्योरिटी ऑफ लाइफ तो हो ही गई। So if you are a college going student, it is the best time to start your preparation, because college is the time to plan for your career, and you have sufficient time over there in the college to plan for the career. But if you have done engineering, then also you need not to regret about it. लेट हो गया है, बट ऐसा तो नहीं है कि लाइफ खत्म हो गई है। अगर अभी से 1 साल 2 साल बैठ करके और एक होलिस्टिक प्रिपरेशन किया जाए, रादर देन कि हर 10 दिन में इस बात की चिंता में डूबे हैं कि मेरा कुछ होगा नहीं होगा। अरे क्यों नहीं होगा? एक पेपर है, उसमें क्वेश्चन है, वो क्वेश्चन तुम कर लोगे, तुम्हारा हो जाएगा। नहीं कर पाओगे, नहीं होगा, ठीक है। और क्वेश्चन करने के लिए तुमको पढ़ना पड़ेगा, पढ़ने के लिए तुम्हें समय देना पड़ेगा और खूब अच्छे से तैयारी करनी पड़ेगी, अपने आप पे भरोसा करना पड़ेगा। सो स्टार्ट प्रिपेयरिंग, स्टार्ट स्टडिंग। एक बार नहीं होगा, दूसरी बार हो जाएगा, दूसरी बार नहीं होगा, तीसरी बार हो जाएगा। तब तक करते रहो जब तक नहीं हो रहा है। इसमें कोई नया मैजिक या जादू है ही नहीं। ज्यादातर लोग इसलिए नहीं सिलेक्ट होते हैं, दे डू नॉट अंडरस्टैंड दिस बेसिक थिंग। फॉर एग्जाम्पल गेट की मैं बात कर लेता हूं। There is a 65 question paper, 100 marks paper. You know it very well कि if you are going to get more than 50 marks in this paper, definitely something would be in your hand. At least कोई ना कोई NIT IIT तो हाथ में होगी ही होगी, ठीक है। worst possible केस में मैं बता रहा हूँ, ठीक। But most of the people, 85% students who appear in the gate, they are not able to get 25 marks. कहां कंपटीशन की बात आ गई इसमें? 100 नंबर के पेपर में तुमसे 25 नंबर आ नहीं रहा है और तुम कह रहे हो कंपटीशन है। अरे नहीं भाई, तुम एक छठे कैटेगरी के बेस्ट क्वालिटी के मूर्ख और आलसी व्यक्ति हो, जिसे मेहनत करना पसंद नहीं है, जो आसानी से चाहता है कि उसको नौकरी मिल जाए। तो कोई भी संस्था ऐसे आलसी व्यक्ति को करियर बनाने की अपॉर्चुनिटी नहीं देगी। कोई भी संस्था ऐसे मूर्ख व्यक्ति को अपने यहां नौकरी दे करके अपनी संस्था को डुबाएगी नहीं। इसलिए आपको कभी भी नौकरी नहीं मिलेगी। जिस दिन आप इस बात को समझ जाओगे, मेहनत करना सीख जाओगे, उस दिन कोई ना कोई नौकरी आपको मिल जाएगी। दैट्स एज सिंपल एज। राइट, यू सी, we have standard relationship what? RT is equal to R naught 1 plus alpha into T. According to this question, at T is equal to the value of when T is equal to 40 degree centigrade, resistance is how much? 4 ohm. Resistance is 4 ohm. When value of temperature is 80 degree centigrade, resistance is 6 ohm. When temperature is 0 degree centigrade, he is asking what is the value of resistance. This you have to tell. Let's try to calculate, use this relationship. If we use this relationship, 4 ohm, we don't know value of R naught, 1 plus alpha into T, temperature. Temperature is 40 degree centigrade. Equation 1. 6 ohm, R naught, 1 plus alpha into 80, equation number 2. So from this if you see 4 by 6 is equal to R naught 1 plus 40 alpha divided by R naught 1 plus 80 alpha, right? And if you cancel these things, so अब क्या होगा हमारे पास? 4 by 6 का मतलब 2 by 3, यहाँ सॉल्व करिए, अल्फा की वैल्यू 1 by 40 आ जाएगी। You put this value of alpha in any equation. So 4 is equal to R naught 1 plus 1 upon 40 into 40. Simplify this, R naught is equal to 2 ohm. So you would be getting R naught, that value is equal to 2 ohm, right? That is 2 ohm. Now my dear friends, you need not to do all these calculations. आपको रीजनिंग इसीलिए पढ़ाई जाती है कि आप उसे अप्लाई कर सकें. This is a linear relationship. You see this, for plus 40 degree centigrade increase in temperature, the increase in resistance is plus 2 ohm. So for minus 40 degree decrease in temperature, the decrease in resistance should be minus 2 ohm. So here the new value of the resistance should be 4 minus 2, that is 2 ohm. सो आप बिना कैलकुलेशन के डायरेक्टली भी सॉल्व कर सकते थे. आंसर फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन बी. जैसे मन करे वैसे सॉल्व करें. यू नो ऑल दीज थिंग्स. प्लीज डू इट क्विकली. गुड. Very good, Abhinav. You have written very good line. If you are going to try, go all the way. Otherwise, don't even start. Done? So this is the first thing. किसी ने लिखा एकदम सटीक बात. देखो, सच बोलना पड़ेगा. मैं आपका टीचर हूँ, मेरी जिम्मेदारी है आपको सच से रूबरू करवाना. मैं एंटरटेनर तो हूँ नहीं कि आपको खुश करके और निकल करके चला जाऊँ. सच यही है कि यू हैव टू डू हार्ड वर्क. बहुत मेहनत करनी पड़ेगी कुछ बड़ा पाने के लिए. हाँ, छोटी मोटी चीज़ों से कंप्रोमाइज़ कर सकते हो तो कोई मेहनत नहीं करनी पड़ेगी. टेम्परेचर पहला फैक्टर था. सेकेंड फैक्टर which is going to affect the resistivity is impurities. Impurities. That is alloying. When we mix two metals, then an alloy is formed, and this process is known as alloying. So basically what we do, let us suppose this is your host metal. Host metal means which is larger in quantity. Suppose it is copper. If it is pure copper, it has BCC crystal structure. It will have very small amount of defect. Those defects can be neglected, and we can say that it has certain amount of conductivity and a very periodic and ideal kind of structure. Now suppose we are wanting to make an alloy and we are adding nickel into the copper. So this nickel will work like impurity. This nickel will function like an impurity. So let us suppose 2% nickel we are adding. So wherever there is nickel in the material, that nickel will try to scatter the electron. So now as you are adding nickel, so you are increasing the defect into the material. And if defect is increased, mobility will come down, conductivity will come down, resistivity will increase, right? So what my point is, कि resistivity of an alloy is always greater than the resistivity of a pure metal, because alloy has more defect as comparison to the pure metal. One more thing you see. It doesn't matter whether you add low conductive material or high conductivity material. Even if you mix silver, still you are going to get the same result, because silver is very small in amount. Conductivity will be mainly decided by the host metal, which is large in amount. That will be responsible for the overall conductivity of the material as bulk conductivity of the material. But even if you add nickel or silver, so wherever they are going, at that point they will try to scatter the electron. So basically they are disturbing the crystal structure, they are making more defect into the crystal structure, and larger the defect in the structure, higher will be scattering, lesser will be mobility, higher will be the resistivity. So no matter what kind of element we are adding, if we are adding any element in a pure metal, then that element is working like a impurity, creating defect into the material, and hence resistivity would be higher. So alloys will have always higher resistivity than the pure metal. So let us suppose copper was pure metal and this is copper and nickel alloy. So resistivity of alloy is always greater than the pure metal. This alloy is known as solid solution. Solution is when two things are mixed, that is known as solution. So it is in the solid state, that's why it is known as solid solution. So इस solid solution की resistivity amount of impurity पर बहुत depend करेगी. The resistivity of this solid solution will be greatly influenced by the amount of impurity. As you keep on adding more and more impurity, it means you are increasing the defect. More defect means higher scattering means conductivity will drop down drastically. So with increase in impurity, with increase in alloy content, resistivity will drop down significantly. So you can write here that resistivity of alloy is always greater than the resistivity of alloy is always greater than the resistivity of pure metal, because alloy has less regular and periodic structure, as compared to pure metal, because alloy has less regular and periodic structure as compared to metal. The conductivity of solid solution alloy drops off rapidly with increase in alloy content. The conductivity of solid solution alloy drops off rapidly with increase in alloy content. Please note it down quickly. जैसे जैसे आप alloy content बढ़ाओगे, alloy content means impurity, alloy content means amount of impurity. As you keep on increasing the amount of impurity, the resistivity will keep on increasing. Please note down quickly. नहीं, बैंकिंग एकदम टोटली डिफरेंट साइड हो जाती है बेटा. सिलेबस देख लो, एकदम 180 डिग्री का सिलेबस नहीं होना चाहिए. हाँ, इफ द सिलेबस इज मैचिंग, मतलब आई डोंट हैव मच आइडिया अबाउट द बैंकिंग, सो इफ यू सी द सिलेबस इज मैचिंग विद योर प्रिपरेशन, देन देयर इज नो हार्म इन अपीयरिंग इन एनी एग्जामिनेशन. बट इफ द सिलेबस इज टोटली डिफरेंट, तो फिर तो थोड़ा सा और ज़्यादा पढ़ाई करनी पड़ेगी. सो एनर्जी स्कैटर बहुत ज़्यादा भी नहीं करना है. Now, I am wanting to see the behavior of this material under temperature, under the influence of temperature. You see, my dear friend, let us suppose I want to plot the resistivity of an alloy with temperature. You see, resistivity of alloy, rho alloy with temperature. Neglect the plastic deformation. Suppose we are not doing as of now the plastic deformation. This temperature is 0 Kelvin. My dear friend, one very important thing. No matter whether we are at 0 Kelvin or 200 Kelvin or 300 Kelvin, if there is suppose 2% nickel, then this 2% nickel will provide certain amount of scattering independent of temperature. First of all, ignore the temperature. This 2% of the nickel will always provide certain amount of defect and those defects will scatter the electrons, and because of which you will have definitely certain amount of resistivity. I am taking that resistivity is like this. It is independent of temperature. It is basically due to the impurity. So if you want to increase this, then you need to increase the amount of impurity. If you want to decrease this resistivity, then you need to decrease the amount of impurity. This resistivity is known as rho residual. अभी ये ग्राफ मत बनाइएगा. This is just to explain. Final graph would be different. I would be telling you. This is rho residual. This rho residual is resistivity due to impurity. Resistivity due to impurity. Due to impurity. It is resistivity due to impurity. Right? This is because of the impurity. Now suppose you start increasing temperature. So at 0 Kelvin temperature is 0. So thermal component of resistivity will be 0. Up to certain temperature resistivity will increase, but that amount of resistivity is very small because lattice vibration is very slow. So thermal component of resistivity can be ignored up to certain value, right? And after that lattice vibration will become quite wide and thermal component of resistivity will become very large. So it starts linearly increase. So this is known as rho thermal. This component of resistivity is known as rho thermal. Thermal component of resistivity increases with increase in temperature and it decreases with decrease in temperature, right? It becomes 0 at 0 Kelvin, whereas residual component is because of impurity, it will not become 0 at 0 Kelvin, right? The value of thermal component below this temperature can be ignored. This value can be ignored. So we can make this graph like this. The actual graph would be, if we ignore this value, because the lattice vibration is very small, value of thermal component is very small as comparison to residual component. So if we ignore this value, then up to this point we have constant value of resistivity, and beyond that resistivity, total resistivity is linearly increasing. So beyond that resistivity, sum of these two components, residual plus thermal, and that is a linear function. So you can have the total resistivity of alloy like this. This is temperature and this is rho alloy. This is 0 Kelvin. Let's start making this graph up to the certain temperature. This temperature I am saying TD, and beyond that temperature it is a linear function, right? This temperature is known as Debye temperature. It is known as Debye temperature. And this component of resistivity is known as residual resistivity. It is known as residual resistivity. This component of resistivity is known as residual resistivity. Debye temperature is that temperature below which thermal component of resistivity is very small and can be neglected. above which thermal component becomes significant and cannot be neglected. So Debye temperature is the temperature above which overall resistivity is sum of residual plus thermal component. Below it, the resistivity is mainly decided by the residual component. Residual component is independent of temperature and remains constant. It will depend upon amount of impurity, whereas thermal components varies with the temperature and it may become 0 even at 0 Kelvin. So overall resistivity of an alloy can be written as rho alloy is equal to rho residual plus rho thermal, and I can write it like this: thermal component of resistivity, yeah, first of all residual component of resistivity of resistivity is independent of temperature and remains non-zero even at 0 Kelvin, remains non-zero even at 0 Kelvin, remains non-zero even at 0 Kelvin. Thermal component of resistivity decreases with decrease in temperature and becomes zero at 0 Kelvin. ठीक है. So this is overall resistivity of alloy. कहाँ से लिखना शुरू करेंगे? यहाँ से प्लीज. जी हाँ, एलॉय में प्रतीक एटलीस्ट रो रेसिडुअल तो रहेगा ही रहेगा, बिकॉज सर्टेन अमाउंट ऑफ इम्प्योरिटी इज ऑलवेज देयर. सर कोई पर्सन आईटी सेक्टर में वर्क करके गेट ईएससी के प्रिपरेशन कर सकता है? जी बेटा, हर साल बहुत सारे बच्चे करते हैं, बस अंतर यह है कि थोड़ा डिसिप्लिन्ड रहना पड़ेगा आपको, और जो भी समय निकाल पा रहे हैं उस समय का सही यूटिलाइजेशन करना पड़ेगा, एंड एज वेल एज ये कोशिश करनी पड़ेगी कि थोड़ा सा क्विक टारगेट की बजाय यू शुड मेक अ टारगेट फॉर लॉन्गर ड्यूरेशन ऑफ टाइम. Longer duration of time, I mean कि at least 1 year preparation you need to give, or even more than that would be required for you, because since you are working person, so you will not be able to give much time for your studies. So if you are working person, try to plan your day every day. Instead of plan, try to repeat it every week, revisit your plan every week, and try to get maximum time in a week so that you can cover syllabus as early as possible. Sir, at the age of 29, can I clear IAS? What should I do to keep myself motivated? Although you are on the verge of age, but now the big motivation is कि IRMS is also there for you. So give one sincere attempt which you have for the IES, and if you could not crack IES, you have studied the technical things, then you will be left with 2 attempts for IRMS also, because in IRMS the age is 32 years, the upper age is 32 years. So अगर आपने कल मुझसे पूछा होता क्या मोटिवेशन है तो शायद कम रहता, बट आज तो ये है कि 29 ईयर्स में यू आर गिविंग ESC, सो टिल 32 अभी 3 अटेम्प्ट बहुत होते हैं, होना होगा तो हो जाएगा, नहीं होना होगा तो नहीं होगा. Residual resistivity is due to impurity. So if you are adding impurity, those impurities will create certain defects. So those defects will scatter electron, decrease mobility, decrease conductivity, contribute in resistivity. So the resistivity because of the impurities is known as residual resistivity. Please note it down. Next, I have repeated it for you. Pratik, you are making wrong conclusion. Alloys will conduct at a higher temperature also, but their conductivity would be less. So it's not like that they will become insulator. They are conducting, but their conductivity is less. Dye temperature is very less temperature, that is in the range of 100 Kelvin. So at that low temperature we cannot have any practical application. So theoretically it is very beautiful temperature, but practically it's useless. Omkar, all these concepts are related with each other. Yes, you are correct. सात्विक बेटा, घर वाले कुछ नहीं जानते हैं, ठीक है, और घर वाले 20 साल पहले की सिचुएशन जानते हैं. कीप प्रिपेयरिंग, स्टे मोटिवेटेड. जब आप सफल हो जाओगे तो वही घर वाले कहेंगे कि मुझे पता था बेटा तुम कर लोगे. ठीक है, ये सोसाइटी का तो काम ही है ना कि सोसाइटी कीप ऑन ड्रैगिंग यू ऑलवेज. सोसाइटी कभी भी ये नहीं चाहती कि कोई व्यक्ति उससे आगे निकल जाए. सो सोसाइटी का काम होता है वो आपको पीछे खींचने का. आपको सोसाइटी के बैरियर्स तोड़ने पड़ेंगे. Let's go. Third factor. The third factor is plastic deformation. Means we are wanting to change the shape of the material. Suppose we have a copper piece and we are wanting to make wire out of this. So we will apply certain force, and if we are applying certain force, then atoms will get dislocated. So whenever atoms are getting dislocated, then the material will have certain defect, and those defects will scatter, electron mobility will come down, conductivity will come down, resistivity will increase. For this plastic deformation, we would be applying some mechanical stress. This stress may be induced because of some pressure or some tensile force. You may be doing cold working, etc. All these factors have same impact. All of these factors are creating defect in the material. So if any one of these is written in the examination and it says that what will be impact on the resistivity, your answer will remain same. What will be your answer? Plastic deformation leads to dislocations in the material. These dislocations scatter electron, thereby mobility decreases, conductivity decreases, and resistivity increases. So please note it down. Plastic deformation leads to dislocations in the material. These dislocations scatter electrons. These dislocations scatter electrons. Thereby mobility decreases and resistivity increases. Mobility decreases and resistivity increases. Copper is very much used as electrical conductor in the industry. So to make wires from copper, we do two kind of processes. One, we take copper and we go to the high temperature. At the high temperature, bonds will become weaker, so we apply a tensile stress and make the copper wire. Then we slowly cool the copper. When we are slowly cooling the copper, this slow cooling process is known as annealing, and such copper wire is known as annealed copper wire. So we have annealed copper wire. In the annealed copper wire, during recrystallization, very slow rate of cooling. During recrystallization, recrystallization, very slow rate of cooling, very slow rate of cooling during recrystallization, very slow rate of cooling. Another, we take the material at high temperature, we do the process, and then we rapidly cool. So such wire where we are doing rapid cooling, that is known as hard drawn wire, hard drawn copper wire, hard drawn copper wire. Hard drawn copper wire during recrystallization, during recrystallization, fast rate of cooling, fast rate of cooling. Basically the process is known as quenching. Now you see, my dear material, he used to ask which one will have higher resistivity or higher conductivity. If there is a slow rate of cooling in this case, then atoms will get sufficient time and periodic arrangement of atoms will result. It means material is having less defect, and if there is less defect, less scattering, higher mobility, higher conductivity, lower resistivity. But if there is a fast rate of cooling, atoms will not get sufficient time to rearrange themselves properly. So there would be large amount of defect. These defects will scatter electrons, thereby mobility will come down, conductivity will come down, and resistivity will increase. So hard drawn copper wire will have higher resistivity than annealed copper wire. So I would be writing it like this: hard drawn copper wire has higher resistivity, bracket में lower conductivity than annealed copper wire. Hard drawn copper wire has higher resistivity than annealed copper wire. Please note it down. Pradyumin, although I have little bit discussed about recrystallization in the last chapter, but I would be discussing it again regarding recrystallization temperature in the chapter known as mechanical properties. So don't worry about the recrystallization. अभी आप ये माने कि ठंडा कर रहे हैं, we are cooling it down. It was heated and we are doing. और कई बार थोड़ा कॉमन सेंस लगाया करो. री मतलब दोबारा, क्रिस्टलाइजेशन मतलब क्रिस्टल बनाना. सो दोबारा क्रिस्टल बना रहे हैं, इसका मतलब पहले क्रिस्टल रहा होगा, गर्म करके उसके मेल्ट किए होंगे, मेल्ट करके दोबारा क्रिस्टल बना रहे हैं. कॉमन सेंस को जिंदा रखो. कैसे मतलब तुम लोग आईएएस बनोगे? Yes, civil and mechanical people have this hard and cold working process. They used to do probably with the steel. मैकेनिकल में तो सब कुछ इसी से जुड़ा होता है. आइए, so this is all about the electrical resistivity. Let's go for the next point. Next one is thermal conductivity of metals. Thermal means heat. So ability to conduct heat. Let's see. Suppose we have this material. This is T1 temperature and this is T2 temperature. We take a small cross section dx, and let us suppose in dx cross section we have temperature difference dt. So thermal flux density, this thermal flux density JQ is, thermal flux density means heat per unit area, right, per unit time. So this JQ is directly proportional to temperature gradient dt upon dx. My dear friend, we know that temperature will move from high to low, so dt will always be negative. So in order to make this quantity positive, एक negative sign लगा देते हैं. So JQ is equal to एक minus sign dt upon dx. This minus is just indicating that the heat would be always going from high to low temperature. dt is negative, so this minus and this minus will become plus. And there is a proportionality constant K, capital K. Here, this proportionality constant will be the material property, which will tell you how the amount of heat per unit area is being transported through the material. So this proportionality constant K is known as thermal conductivity. It is known as thermal conductivity of material. This thermal conductivity is basically ability to conduct heat, through the material, This is known as thermal conductivity. So higher the value of thermal conductivity, more will be the heat flow through the material. This thermal conductivity mainly depends upon two factors. Thermal conductivity mainly depends upon two factors. One, if you recall, I told you that when atoms vibrate, so this vibration is transferred to the neighboring atoms. These atoms vibrate because of thermal energy. So if you increase the temperature at it, vibration will take place. This vibration will give energy to the next and next one to next. This way, these atomic vibrations are used to transport heat from one end of the material to the other end. So the first factor is atomic vibration. I said that one quantum of atomic vibration energy is known as phonon. So basically the first responsible particle is phonon. The second one is electrons. Electrons are free. ये बेरोजगार लोग हैं, इनको कोई फर्क नहीं पड़ता है कि इन्हें कौन सा काम मिल रहा है, बस काम चाहिए, ठीक है. So they are free. They will take electrical energy, they will take magnetic energy, they will take thermal energy, they will take optical energy. Any kind of energy you will give them, they will take and run away. So the second responsible factors are free electrons. These are the free electrons. So total resistivity, electrical conductivity is due to phonon plus electron. Electron means by default free electron. These two will decide the total total thermal conductivity of a material. Please you note down this, then I have to tell few things here. Yes, annealing is there also. कैसी चल रही तैयारी अभिलाष? इफ आई एम करेक्ट, आपने मुझसे ईडीसी भी पढ़ा है शायद. Shall we go ahead? Right. So thermal conductivity. Now suppose you have any material which is electrical insulator. So if the material is electrical insulator, suppose you are having an electrical insulator, it means it does not have free electron, because if it would have free electron, it would have been electrical conductor. So K electron component is negligible for this material, and if K electron component is negligible, then overall thermal conductivity is mainly because of atomic vibration. Generally, the materials which are bad conductor of electricity, they are also the bad conductor of heat, because one factor is absent there. But there are few exceptions also. One of those exceptions is diamond. Diamond is electrically insulated because it does not have any free electron, but it is thermally excellent conductor. Why? I told you in diamond the packing efficiency is 34%. It means 66% volume of the cell is void. Because of such a wide volume, atoms can vibrate so freely. So when you give them heat, the atomic vibration becomes very large, and that atomic vibration will transport a large amount of heat through the material, and hence this diamond becomes a very good conductor of heat. But this generally does not happen with the other materials, because in other materials which are electrical insulators, like suppose ionic materials, they have very heavy packing efficiency, and because of high packing efficiency, atomic vibration scope is very less. So those materials are not able to conduct heat very effectively. So most of the materials which are electrical insulator, they are also thermal insulator, but diamond is exception out of this, because diamond has very low packing efficiency, which gives it a probability of very high atomic vibration. As a result, large amount of heat can be transported through the diamond, and diamond becomes excellent thermal conductor. So in diamond, whatever is the thermal conductivity, that is due to the lattice vibration. Diamond is electrical insulator. Diamond is electrical insulator. Electrical insulator. But it is excellent thermal conductor. Excellent thermal conductor. It is excellent thermal conductor. You can write it this. Now suppose we are talking about metals. Metals are having both atomic vibration as well as free electrons. So metals are having both components. You are having free electrons in the metals. So K is due to the electrons, as well as you have phonons also. But you see, phonons are lattice vibration. In metals, packing efficiency is high. Suppose we are talking about copper. Copper is FCC. FCC has packing efficiency 74%. It means only 26% of volume is void. So chances of atomic vibration are very less. Although vibration will take place, but the amplitude of vibration is very small. So amount of heat transported because of lattice vibration would be very small. Most of the heat would be transported because of the free electrons. So almost 80% contribution is because of these, and almost 20% contribution is because of these. So in metals, most of the heat is being transported due to free electrons. We can say that electrons are responsible mainly for both of the conductivities, thermal as well as electrical in the metal. If electrons are responsible for both types of conductivities, thermal as well as electrical, then there must be some relationship between thermal and electrical conductivity, because the same particle is taking role in electric conduction as well as it is taking role in thermal conduction. So same particle is participating in both types of conduction. It means these conductivities must have some relationship. So that relationship is given as K is equal to sigma LT, that is LT by rho. LT by rho. What is this relationship is saying? Have a look. K is known as thermal conductivity. Thermal conductivity. Conductivity, and sigma is electrical conductivity. Electrical conductivity. Rho is reciprocal of electrical conductivity. So rho is 1 upon sigma. L is Lorentz number. Lorentz number. And it is a constant basically, and T is temperature. This temperature is in Kelvin. This temperature is in Kelvin, right? Now this equation is known as Wiedemann-Franz law. This equation is known as Wiedemann-Franz law. What is the use of this law? It establishes a relationship. It establishes a relationship between thermal and electrical, conductivity of metals. Electrical conductivity of metals. It establishes a relationship between thermal and electrical conductivity of metals. That is the utility of Wiedemann-Franz law, because both of the conductivities are mainly because of electrons. So if the particle which is participating in the conductivity is same, then these conductivities must have some relationship. That relationship is established by the Wiedemann-Franz law. Wiedemann-Franz law is saying that K is equal to sigma LT, where L is a constant, Lorentz number is a constant. That's good, Abhilas, and it's very good. That is the time to do the things. श्रुति, I told you कि अगर आप सिविल सर्विसेज और IRMS फॉर्म भरते वक्त दोनों पर मार्क करोगे तो आपका अटेम्प्ट काउंट होगा सिविल सर्विसेज का, लेकिन अगर सिर्फ IRMS पर मार्क करोगे तो फिर आपका अटेम्प्ट IRMS के लिए काउंट होगा, सिविल के लिए काउंट नहीं होगा। और अगर आप दोनों दे रहे हो तो दो अटेम्प्ट नहीं काउंट होगा, दोनों एग्जाम का एक ही एक अटेम्प्ट काउंट होगा। Milu is asking, sir, entire syllabus will be completed by the December. It depends upon the batch to batch. In some of the batches it would be completed, but those batches which start very late, like those batches which started in June, their syllabus will not be completed. They will go up to roughly around 10 January. Now, if electrical and thermal conductivities are related with each other, then there must be some relationship between thermal phenomena and electrical phenomena. So, such relationships are known as thermoelectric effects. Thermoelectric effects. Electric effects means electricity due to temperature or vice versa, temperature due to electricity. So, such kind of effects are known as thermoelectric effects, right. First one is Seebeck effect. Seebeck effect. The first one is Seebeck effect. What does it says? Have a look. It is saying that if you take two different metals, suppose this is a metal A and you take another metal, let us suppose this is metal B, and you connect them, then at one junction you increase the temperature, that will be known as hot junction, and other junction you decrease the temperature, that will be known as cold junction, right. So, because of temperature difference, electrons will start to move from hot to cold, because they have to transport heat from high to low end. So, when electrons will leave this end, a positive charge will be developed here, because earlier it was neutral. When electrons are leaving this end, then at this end there would be a positive charges left, and electrons are reaching to this end at the cold side, so negative charge would be developed here. So, a positive to negative charge means a potential difference is developed across the material, and if a potential difference is developed, then an EMF will be induced, which is high at the hot end and low at the cold end. This phenomena is known as Seebeck effect. So, Mr. Seebeck is saying that we take two metals and join them, and if one end of the metals is kept at high temperature than the other, then an EMF is developed due to this temperature difference. Means a voltage would be produced due to this temperature difference. EMF means voltage, electromotive force, that is basically nothing but voltage. And if there is a voltage or potential difference across two ends of a conductor, then a current will definitely flow. So, there will be a current here also. This effect is used in measuring temperature and making an instrument that is known as thermocouple. But क्योंकि हम मटेरियल साइंस पढ़ रहे हैं, इंस्ट्रूमेंट्स नहीं पढ़ रहे हैं, तो हम उसकी बात नहीं करेंगे, सिर्फ इस इफेक्ट को लिखेंगे. So we can write like this: when two different metals are joined at their ends, when two different metals are joined at their ends, and one end is kept at high temperature than other, then an EMF is developed across both ends of the material. This is known as Seebeck effect. This is known as Seebeck effect. This is known as Seebeck effect. When two different metals are joined at their ends and one end is kept at high temperature than other, then an EMF is developed across both ends of the material. This is known as Seebeck effect. इसका converse भी होता है हमारे पास. Here, due to temperature, we are getting voltage. yeah, current. So we have a converse is also, that is known as Peltier effect. Peltier is saying that when two metals are joined at their ends and a current is flowing through them, then due to this current a temperature difference would be developed across the material. जो बात सीबेक ने कही थी उसी को इसने उल्टा कह दिया. So he is saying that कि सीबेक कह रहे हैं कि because of temperature there is a current. So I am saying that कि because of current there would be temperature. So Peltier effect is nothing but converse of Seebeck effect. It is converse of Seebeck effect. Converse of Seebeck effect. Seebeck effect. When two metals are joined, when two metals are joined, and a current is flowing through them, and a current is flowing through them, then a temperature difference is developed across the junctions. Then a temperature difference is developed across the junctions. Then a temperature difference is developed across the junctions. This is known as Peltier effect. Peltier effect. This is known as Peltier effect. Please go far. किसी ने अभी पीछे भी नहीं लिखा था, जल्दी से लिखो, यहां से लिखना था किसी को. Quickly do it. ESC and IRMS both are different examinations, so attempt will be different. If you appear in ESC, then your attempt for is counted is for ESC. If you attempt in IRMS, your attempt would be counted for IRMS. So they are not same, they are totally different. Even they will be conducted at different time. ESC pre is conducted in January and IRMS will be conducted in June. So they are not related with each other, they are totally different. Yes, pressure is made up a Peltier effect. You are 100% correct, Omkar ji. Do it quickly, please. Noted? बेटा EMF इलेक्ट्रॉन की डायरेक्शन पे नहीं डिपेंड हो रहा है. EMF is depending upon from where electron is going. So the place from where electron is going, at that point you will have positive charges, it means higher potential, and where electron is reaching, there you would be having negative potential. Ankush is saying that, sir, are the other departments of ESC not good because railway is given so much importance? ऐसा तो नहीं है मेरी नज़र में. देयर आर सेवरल वेरी गुड डिपार्टमेंट, CPWD, सेंट्रल पावर, एंड MES, मिलिट्री इंजीनियरिंग सर्विसेज, naval armaments, Indian radio regulatory. These all are very good departments. But why railway is given so importance? No doubt railway was best among all these, because railway is the largest network in India. So all over India you will be having some facilities related with railway. First thing. Second thing, railway has very large number of vacancies. You see, sir, total vacancies in ESC is roughly around 300 something, and railway itself has 150 vacancies. So railway is actually having large number of vacancies for the engineers, and that's why railway was given so much importance rather than other departments. Other departments are having only 10, 20, 30, 40 seats like that, but railway is having large number of seats. Who said we can't generate electricity due to temperature difference? We can generate, but that would be idiotic phenomena, because to generate the temperature we must have some energy. Temperature भी तो किसी energy से आएगा. So we can generate electricity with temperature, no problem. आपको किसने कहा कि temperature से electricity नहीं कर सकते? This was all about the metals. I said that this whole chapter would be divided in three broad categories. First one is conductor, second one is semiconductor, and the third one is insulator. So let us go for the part 2. Part 2 of this chapter is conductors. Part 2 of this chapter is conductors. Sorry, semiconductors. Conductors we have studied. So let's go for semiconductors. Very important. You will be getting several times questions from this topic. In fact, total 9 questions has been asked from this chapter, and out of 9, probably 5 are from this topic. किसी ने पूछा है कि which one is best among PSU, IAS and IRMS. अभी जब तक आप अनएम्प्लॉयड हैं तो जो सबसे पहले मिल जाए वही बेस्ट है. ठीक है, जब एक जॉब मिल जाएगी उसके बाद मुझसे कांटेक्ट करिएगा, मैं बताऊंगा कि उससे बेहतर कौन सी है. बट अंटिल यू आर नॉट गेटिंग एनी जॉब, सो व्हिच वन विल बी द फर्स्ट फॉर यू, दैट इज द बेस्ट. प्लीज कम टू द पॉइंट. Semiconductors are the materials. Semiconductors are the materials which have electrical conductivity, greater than the insulators, but less than the metals. These materials have very narrow energy band gap, as compared to insulators. These materials have very narrow energy band gap as compared to insulators. Please define it. Although we have already defined it, but still. Noted? Right. Let's come back. These semiconductors are classified in two ways. First, intrinsic semiconductor. Am I audible? Yes. Intrinsic semiconductor. These are classified in two ways, intrinsic semiconductor, and the second one is extrinsic semiconductor. Extrinsic semiconductor. Extrinsic semiconductor is further classified in two broad categories, N-type semiconductor and P-type semiconductor. P-type. We have to study all this in this topic. ये सारा हमें पढ़ना है. Please do it quickly. Thank you. है पी तो लिया मैंने, अब जैसा भी होगा. आइए. So one by one, let us start studying these semiconductors. So first begin with intrinsic semiconductor. Intrinsic. Semiconductor. Sometimes in the examination he would be writing it as pure semiconductor. Intrinsic means pure. So semiconductor in its purest form is known as intrinsic semiconductor. कोई semiconductor अपने pure form में intrinsic semiconductor कहलाएगा. A semiconductor in its purest form is known as intrinsic semiconductor. कोई भी semiconductor अपने pure form में intrinsic कहलाता है. My dear friend, we have several semiconductors like silicon, germanium, and gallium arsenide, gallium nitride, indium phosphide. There are large number of semiconductors. But out of all these materials, silicon is the most widely used semiconductor material. What is the reason behind the most wide use of semiconductor? हाँ प्रतीक दे गए. प्यास लगी थी, कोई ध्यान ही नहीं दिया. कोई नहीं, ठीक है. It's okay. Most widely used semiconductor material. So silicon is the most widely used semiconductor material. Why silicon is most widely used semiconductor material? The reason is it is hugely abundant in nature. Silicon is extracted from silica. Silica is SiO2. It is hugely abundant in nature. So from this silica we extract silicon, and this silicon is our semiconductor material. So if it is hugely abundant, its cost would be less, and if the cost is less, industry would be using it more. So industrially the most useful semiconductor material is silicon. So I would be explaining everything with respect to silicon. That is equally valid for the other semiconductor materials also. Why I am using why I am taking silicon for the explanation? Because it is the most used semiconductor material. Why it is the most used semiconductor material? Because it is hugely abundant in nature, so its cost is very less as comparison to the other semiconductor materials. Now we are talking about intrinsic semiconductor. Intrinsic means pure semiconductor. So a semiconductor in its purest form is known as intrinsic semiconductor. But कोई भी semiconductor क्या 100% purify किया जा सकता है? No, it's not practically possible. So we say that कि out of 100 million parts of semiconductor, if there is less than 1 part of impurity, then the material is known as pure. Otherwise it cannot be said as pure. So we need a very high level of purity, 100 million parts of semiconductor, then less than 1 part impurity. So impurity content should be negligible, then only the material will be known as pure semiconductor. So first of all, we can write it a semiconductor in its purest form is known as intrinsic semiconductor. A semiconductor in purest form is known as intrinsic semiconductor. Intrinsic semiconductor. A semiconductor in its purest form is known as intrinsic semiconductor. We know that silicon is in the fourth group. So it has 4 valence electron. Actually the atomic number of silicon is 14. Its atomic number is 14. So it has 2, 8 and 4. The inner two, these are the core electrons. They do not participate in the bonding. So bonding is done by this electron. This is the valence electron. So we would be talking everything with respect to the valence electron. So when silicon semiconductor, a solid is formed, large number of silicon atoms will be coming closer to make the solid. So these are the silicon atoms which are coming closer to make the solid. These are the silicon atoms. So we have large number of silicon atoms and all these silicon atoms are coming closer to make solid. They are coming closer to make solid. ये सभी solid बनाने के लिए एक दूसरे के करीब आ रहे हैं. All of them are having 4 valence electron. So all of them have 4 valence electron. All of them are having 4 valence electron. All of them are having 4 valence electron. All of them. These atoms will share electron with the neighboring atoms and hence they will make covalent bond. Sometimes they used to ask a question which kind of bonding is found in semiconductor. So you can see clearly the bonding type in the semiconductor is covalent bond. So we get covalent bond in the semiconductor. So this is the covalent bond they are forming with the neighboring atom. So we have large number of covalent bonds. So this bond is covalent bond. This is also a popular question, which kind of bonding is found in the semiconductor. So we have covalent bond. Since it is a solid, so to represent the energy of electron in the solid, we need to draw a band diagram. So for this silicon, we have a band. We have valence band. Top edge of the valence band is EV. We have conduction band. Bottom edge of the conduction band is EC. And there would be a forbidden energy gap represented as EZ. My dear friend, you see, initially, let us suppose we are wanting to see the behavior of this material at 0 Kelvin. Suppose I am wanting the behavior of this material at various temperatures. So first of all, I am considering the 0 Kelvin. First of all, I am considering the temperature that is 0 Kelvin. Right. So if I consider the temperature that is 0 Kelvin, at 0 Kelvin we are wanting to see the behavior of the material. Case 1, that is at T is equal to 0 Kelvin. We are wanting to see how does the material behaves at 0 Kelvin. So there is no external energy, there is no thermal energy available. All these electrons have participated in the bond formation. So they would be in the lowest energy states. It means all these electrons will be in the bond, and bonded electrons are found in valence band. So valence band is fully filled. This band is fully filled. ये band पूरी तरह से भरा हुआ है, ठीक है? But there is no thermal energy. So no electron can reach from valence band to conduction band. If you will have thermal energy, then electron will take that energy and will be moving towards the conduction band. But since you are not having any thermal energy, so no electron can move from valence band to conduction band. It means conduction band is empty. Conduction band is empty. Let me tell you a situation. Let us suppose there is a class. In that class there are 100 chairs and each chair is occupied by a student. Even a single chair is not empty. All the chairs has been occupied by the students. Now I went to the class and I start to motivating students that you should move जीवन में चलते रहना चाहिए, you should have some dynamism in the life, so start moving. They want to move but they can't move. Why they cannot move? Because there is no place for the movement. All the chairs has been already occupied by someone, so there is no empty space to move them. This is the case of the balance band. In balance band there are 4 n states, and at each state there is one electron. So when you apply voltage, because of that voltage these electrons want to move but they cannot move because there is no place for their movement. Hence these electrons cannot contribute into the current, because there is fully filled band, and fully filled band electrons does not have any space to move, and therefore they will not be contributing into the conductivity. So because of these electrons we are not going to get any conductivity at 0 Kelvin. Now suppose there is a classroom, and in that classroom there are 100 chairs but there is no student. Now I start shouting in the class that everyone should move, there should be dynamism in the life, why are you staying here, you should start moving. Is there any motion possible in that class? No, because chairs cannot move and there are no students on the chair, so there is no possibility of any motion in that case also. That is the case of conduction band. In conduction band there are lots of empty space but there is no electron, and if there is no electron there is no possibility of motion. It means at 0 Kelvin in this material, no matter what amount of voltage you apply, there is no movement of charge, and if there is no movement of charge there is no current. There is no current, it means this material is an excellent insulator. दूसरे शब्दों में आप ये कह सकते हो कि in the semiconductor at 0 Kelvin, all the electrons are participating in the bond formation, and bonded electrons are not able to move. Hence you do not have any free electron, and if you do not have any free electron then the electrical conduction is not possible. So this material is an excellent insulator at 0 Kelvin temperature. So they used to ask you at 0 Kelvin temperature what will be the behavior of semiconductor. Your answer is lack of free electron, it means 0 conductivity, hence it is a excellent insulator. So perfect insulator. At 0 Kelvin an intrinsic semiconductor would be behaving like a perfect insulator. So please note down, at 0 Kelvin, 0 Kelvin is known as absolute zero temperature. Absolute zero temperature, no thermal energy is available. No thermal energy is available. So no electron can reach to conduction band. Therefore conduction band remains empty. Conduction band remains empty. And valence band remains fully filled. Hence at 0 Kelvin, we do not have any free electron. In the semiconductor. Therefore at absolute zero temperature, at 0 Kelvin an intrinsic semiconductor behaves as a perfect insulator. An intrinsic semiconductor behaves as a perfect insulator. an intrinsic semiconductor behaves as a perfect. Therefore, at 0 Kelvin, an intrinsic semiconductor behaves as a perfect insulator. Please note it down. ये आप बना लीजिए और इसको लिखिए. ये है केस 1 जब हम 0 Kelvin पर हैं. Then the behavior of the material. Please note it down. Done? Is it done? Pratik is saying that why carbon does not behave as semiconductor. Very simple option. In carbon, basically carbon is diamond. If so, in diamond sp3 hybridization takes place, and because of that sp3 hybridization, the potential energy of the carbon-carbon covalent bond goes very low. And if potential energy is very low, then bond will be very strong. And if the bond is very strong, then band gap would be wide. So in diamond, the band gap is 5.5 electron volt. That is very high, and because of which diamond starts behaving like an insulator rather than a semiconductor. So I have done already the classification based upon the band gap. If band gap is wide, material will be insulator. If band gap is narrow, material will be conductor, right? Yeah, semiconductor. In diamond, band gap is wide, that is 5.5 electron volt. So diamond is behaving like an insulator. आज के लिए बस इतना ही. In the next class, we will be trying to study the case 2, where we would be discussing the behavior of semiconductor, intrinsic semiconductor at non-zero temperature. But today we have discussed the behavior of semiconductor at 0 Kelvin temperature, and at 0 Kelvin it is behaving like a perfect insulator, like an ideal insulator. आज के लिए बस इतना ही. Thank you very much. We will be meeting in tomorrow's class. Tomorrow we will be covering semiconductor and insulator, both topics, and after that we will be moving towards the next chapter. So let's meet tomorrow's class. Thank you. Have a wonderful day.